Hello everybody, this is problem number 2.26 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. In this electrical network, we are asked to calculate Ix and the total power absorbed by the entire circuit. And this I naught current is given here as 3 amps. Okay, so using the given data, we need to calculate this Ix. Ix is the current entering into this 10 ohm resistance and it's flowing through that resistance. And this I naught, that is the 3 amps current, is flowing through the 16 ohm resistance. Since the I naught current is given as 3 amps, that is flowing through this 16 ohm resistance, we can calculate this V naught. V naught is the voltage across the 16 ohm resistance, that is equal to I into R, isn't it? This I naught into that R. So it is equal to 3 into 16, that is equal to 48 joules. So the 48 joules will be available across this 48 volt voltage is existing across the 60 ohm resistance. And here we can see that this 2 ohm resistance, this 4 ohm resistance and this 8 ohm resistances are in parallel with the 16 ohm. So across these resistances also the same voltage exists. That means this 48 volts will be existing across these resistances also because they are parallel. So once you know this voltage, you can calculate easily the current, isn't it? So what's the current which is flowing through this 2 ohm resistance? Okay, so we can calculate the current. So the current which is flowing through this 2 ohm resistance can be calculated using the Ohm's law, right? V by R. So 48 divided by 2, that is equal to 24 amps. Similarly, we can calculate the current which is flowing through this 4 ohm resistance, that is equal to that volt divided by 4, that means 12 amps. Really, this current flowing through this 8 ohm resistance is equal to 48 divided by 8, so it is 6 amps. So we got all the currents through these resistances except this Ix, right? Now we can calculate this Ix. Ix is the current entering into this particular node. All other currents are the leaving currents here. If you take this as node 1 and this is your reference node, then at node 1 we can apply KCL. KCL is Kirchhoff's current law. It states that in a particular node, sum of the incoming currents is equal to sum of the leaving currents. So incoming current is Ix, that is equal to leaving currents, this I 8 ohm plus I through this 4 ohm plus I through this 2 ohm resistance plus this I through this 16 ohm resistance. All these values we know, right? So it is 6 plus I4 ohms. So this second current is 12 plus this I through the 2 ohm resistance is 24 plus I through this 16 ohm resistance is 3 amps, isn't it? So now if you add all these currents, then we'll get this Ix. It is 45 amps. So we got one answer. But one more question is here asked. Calculate the total power absorbed by the entire circuit. So we have this 10 ohm resistance. In the 10 ohm resistance, the total power, the power absorbed, that is equal to I square R. So we calculate the power as I square R, isn't it? So I is 45 square into this 10. That much watts. So it is 2025 into 10. That means this much watts power is absorbed here. And in this 8 ohm resistance, it is equal to that I square R formula. Again we are going to use, that is the formula for power. So that current is 6 amps, isn't it? So 6 square into 8. So that is equal to 36 into 8. So that's equal to 288 watts. Then power absorbed by this 4 ohm resistance, that is equal to the current flowing through that 4 ohm resistance, that is 12. So 12 amps square into that resistance is 4 ohm, isn't it? So it is 144 into 4, 576 watts. Then we have the next calculation to be done is the power absorbed by 2 ohm resistance. The current is here, it is 24 watt, 24 ohms. The current flowing through that 2 ohm resistance is 24 amps. So it is 24 square. This we have calculated here, isn't it? So 24 square into 2. That is 576 into 2. So it is 1152 watts. Then the last one is P through this 16 ohm resistance, that is equal to, the current is given as 3 amps, isn't it? So 3 square into 16. So it is 9 into 16 is equal to 144 watts. So the total power absorbed can be calculated by adding all these powers. So all these powers should be added, okay, to get total power absorbed. Total power absorbed by the circuit, that is equal to 410 watts. This is the answer for us. This is the total power absorbed in watts. This can be written as 22.410 kilowatts. So in another method also we can calculate this power absorbed by the entire circuit. So we have already calculated this as 45 amps. This Ix was already calculated by us as 45 amps. Now for this circuit you can calculate this R equivalent. All these resistances are connected in parallel, isn't it? So for these circuits we can calculate the equivalent resistance for these 4 resistances as 1 by R equivalent is equal to 1 by 8 plus 1 by 4 plus 1 by 2 plus 1 by 16. So if you calculate, this is 1 by 8 is 0.125 plus this is 0.25, 1 by 4 is 1 by 2 is 0.5 plus 1 by 16 is 0.0625. So when you add all these things, we get this as 0.9375. So this is 1 by R equivalent. So what is the R equivalent for this when it is equal to 1 divided by this 0.9375. This is equal to 1.0667. This much ohms. So this circuit can be replaced by, so this is your 10 ohms. Here we got the R equivalent, that is 1.0667 ohms. Okay, like that it is given. Here we have this Ix. So these combination now, these two are in series now, isn't it? These two resistances are in series. So we can add them so that we'll get the new circuit, and it is, out of this we get the circuit as a single resistance of 11.0667 ohms. This is the new equivalent circuit we got, isn't it? In which the current flowing, that is Ix, which is already found to be 45 amps. So this is your R equivalent and this is your Ix. So now you can easily calculate the power or the total power, that is equal to I square R. So this is Ix whole square into this R equivalent is now 11.0667 ohms, isn't it? So it is 45 the whole square into 11.0667. So the 45 square is 2025 multiplied by 11.0667. So it is equal to 22,410 watts. So we can write this as P total is equal to 22.410 kilowatt. Okay. So this is the answer we got already. Okay. Hope you have understood. Thank you.